Hey folks, Doug Blake with Body Design University, and in today's video, going to talk about a table in chapter 14, table 14.1. This is the flexibility training chapter. So I wanted to kind of go over some issues and concerns I know that students have asked me related to this particular table. And for the most part, and by the way, this is on page 440 if you have your actual textbook, hardcover textbook. Of course, there's always the online digital, which is right here. And you can find that this is, of course, in there, the NASM's online lesson 1. And this is the introduction to flexibility training. But table 14.1 has caused, a little bit of concern and interest because folks are reading it. They don't understand why terminology is used the way it's used. And, for the most part, they'll generally ask me, how come the word shoulder extension is used, whereas the muscle actually does shoulder flexion or something related to the kinesiological function? This relates back to other issues that we normally see with kinesiology, which is terminology that can get confused with terminology from other fields of study, like biomechanics. Just as a, for instance, I was talking with a student who had an issue with flexion and extension versus concentric and eccentric contractions, because if you think about it, the term flexion sounds very much like flexing a muscle, right? And so we can confuse the terms, and we want to make sure that we differentiate the number one, the terminology, what they mean, so that we can bring it together into a more cohesive explanation of exactly what's going on in the human movement system. So, but chapter 14 gives us a great opportunity to kind of get a good understanding of exactly what is happening when we're talking about issues related to flexibility. And that's what the chapter is about. So if you are interested in using your textbook, this is page 440. I'm going to get that out of the way. But when we look on the actual table itself, for the most part, it's a chart, right? It's giving you 3 muscles, and it's talking about what's known as multiplanar flexibility. And what's the whole point here with flexibility is that, for the most part, NASM is very interested in helping you to understand movement patterns and how muscles move through normal functional movement. In other words, the pulling and the pushing, the double leg squat, single leg squat, things like that. All of the bending, lifting, movement patterns that involve a good amount of muscle over a number of joints. But at these joints, you're going to find muscles that, as you can see in table 14.1, require flexibility in all 3 of the 3 ranges of motion: the frontal plane, sagittal, and the transverse plane. So probably an idea that you obviously know what those terms mean. So if you remember the different planes of motion, the frontal plane describes movement, frontal plane out to the side, right? So the arms, abduction and adduction. If the legs and hips, for instance, are moving out to the side, that's the frontal plane, frontal planar movements, right? Abduction, adduction. Okay, so it's critical that you remember those terms. Sagittal plane is movement to the front, right? So flexion, extension. And in the case, by the way, if you look here, in the case down here in the gastroc, they're going to use some terms that you also need to know. And those terms are dorsiflexion and plantar flexion. But at least I got the words in there, right? Flexion. So that's movement in the sagittal plane at the ankle, very specific. And then, of course, transverse planar motion, internal, external rotation. I know that for the most part, the concept, the 3-dimensional nature of understanding planes of motion is going to be a little confusing, but that's why it's kind of helpful to go through this. And so the questions that I normally get related to table 14.1, multiplanar flexibility, is if you look at the name of the muscle, not a problem. They give you a really good image, by the way. They're letting you know that the latissimus dorsi is going to function in some way, shape, or form when it goes through its concentric, eccentric contractions. It's going to perform, or capable of performing, movement in all 3 planes of motion. in the sagittal plane, in the frontal. Don't look over here yet. Don't look at the movement part yet. Stay with me. We know, and if you kind of put your hand, like I can put my hand over the screen, if you look at just the lats, just stay with me here on just the lats. What are the standard kinesiological functions? And when I say kinesiological functions, I'm asking you to tell me the lats perform shoulder extension. The lats perform shoulder adduction. The lats perform shoulder internal rotation. Okay, so when you talk about kinesiology, we're talking about just the terms. Okay, so muscles perform kinesiological functions. Muscles flex at a joint, or muscles extend at a joint. And you should know the major muscles of the body and what their main or basic kinesiological, standard kinesiological functions are. Just as a for instance, we'll take a little aside here. What is the kinesiological function or functions of the deltoid, the shoulder? You should immediately say shoulder abduction, abduction, right? So what is abduction? It's movement away from the midline of the body. What do the biceps do? Elbow flexion. Okay, does that make sense? Triceps, elbow extension. So when you know the kinesiological terminology, now you can take a look over at this last column, the movement, multiplanar flexibility. And really what they're telling you here is that if you know what the actual kinesiological function of the lats are, then you'll know that the opposing or the opposite term is what a properly flexible, or a muscle with proper extensibility, right? Extensibility is the ability for soft tissue. In this case, we don't care. We're talking about muscles, right? Muscles to elongate and stretch. And there are normal extensibility parameters that we have or know for particular muscles of the body. Some muscles have a extensive ability to lengthen, right, and shorten. And if you, for some reason, have an issue with that proper extensibility of that particular muscle, this is where we, and NASM will let you know, this is where we see problems. By the way, postural distortions, all of these issues that we see are related to, in some way, shape, or form, muscle flexibility or lack of extensibility. In some cases, listen to the terms I use. In some cases, these muscles become overactive or they are underactive. Okay. See, a lot of this stuff starts to come together when you think about just the straight physiology of muscles. So if a muscle is shortened, right, and it shortens, it doesn't have normal extensibility. It's not going to be able to lengthen. You're not going to be able to stretch it, right? So it pulls and shortens at a particular joint. So hopefully you can just see how that kind of forms in. Don't get into overactive, underactive with this quite yet. But here's what I want you to see on this. Now, when you look at what is the sagittal planar motion, kinesiologically in the sagittal plane, what do the lats do? What is their kinesiological function? Shoulder extension. Okay, so the lats perform shoulder extension, right? So if the arm is raised up in front, it pulls it back down, so to speak. So therefore, from an extensibility, the ability to lengthen means that it must have what? Proper extensibility to allow for the opposite of its normal kinesiological function. In other words, shoulder flexion, that's not what the lats do. The lats extend the shoulder, right? They pull the arm down and back. So if they pull the arm down and back, then the opposing movement, flexion, right? If my lats perform extension, then the opposing movement that they need to be able to elongate and stretch into is going to be shoulder extension. So if I can lift my arm up all the way right up in front of me, this is shoulder flexion. If the lats are too tight, they want to stop shoulder flexion. They actually want to continue to pull and maintain shoulder extension. So extensibility with relation to the lats in the sagittal plane means that the lats have to be able to extend. They have to be able to, the muscles need to be able to stretch and extend to allow for flexion to occur. What do the lats do kinesiologically? They extend. If they're constantly trying to extend the shoulder, then the shoulder can't properly flex. This is why the overhead squat assessment is a really good test, or at least one really good test to get an idea of the overactive nature of the lats. It's one of the reasons why the lats in general are going to be overactive, right? We see this for the most part because people are internally rotated in their shoulder, which is a function of the lats, by the way, just so you know. And so I hope that makes sense. So in the sagittal plane, when you're reading table 14.1, the lats perform their kinesiological function as shoulder extension. Therefore, their extensibility needs to allow for shoulder flexion. In the frontal plane, right, out to the sides, right, like jumping jacks, doing jumping jacks. Well, what do the lats perform? What's their kinesiological function in the frontal plane? It's shoulder what? Adduction. So the lats, what do the lats do? They extend, they adduct, they internally rotate. So they adduct. That's why when you do a pull down or pull-ups, you're adducting the shoulder, and that's what the lats. What's one of their main functions in the frontal plane, okay? So in order for the lats to perform properly, this movement of adduction, right, they're shortening, and that's their kinesiological function. If they are not extensible enough, if they don't have proper extensibility, you're not going to be able to do the opposite movement. And what's the opposite kinesiological movement of adduction? It is abduction. Hope that makes sense. So your lats must have proper extensibility to allow for the opposite of what their normal kinesiological function is. If their normal kinesiological function is adduction, then they must have proper extensibility to allow for the opposite of adduction, which is shoulder abduction. If they're overactive and they're pulling on me, they're not going to allow you. You're going to end up doing that. You're going to end up, elevating, right, the shoulder girdle, right? So the point is that if you think of it from this perspective, that they have a kinesiological function, they need proper extensibility to allow for that joint to go through the opposite of what their kinesiological function is. So in other words, they adduct in the frontal plane. So they need to have extensibility, proper extensibility to allow for abduction, right? Proper shoulder abduction. And now all we do is we look at the transverse plane. And what do the lats do? Well, we know that the lats, because of their insertion point into the internal aspect of the humeral head, not the humeral head, but the humerus itself, because the lats attach sort of internally, medially inside to the humerus, that it actually internally rotates. It acts as an internal rotator to the shoulder, right? And so what's the opposite of internal rotation? External rotation. You notice that they must have extensibility, proper extensibility to allow for what? Well, the opposite of what their normal kinesiological function is. If the normal kinesiological function is internal shoulder rotation, proper extensibility should allow for external shoulder rotation. Okay, this is by the way, this is an interesting scenario, because we see this all the time, pretty much, with the average person who sits like I'm doing here. I'm sitting at a computer, and you know this, right? We protract, which is the movement of the shoulder girdle forward. So the shoulder girdle moves forward, and we internally rotate, which basically does what? It shortens the muscles, the lats, right? So internal rotators get shortened. Pectoralis, same thing. This entire postural issue that we see with folks where they are protracted, the head drops down or juts forward, and we have this collapsing of the spinal column downward and the internal rotation of the humerus. this causes any number of the issues that we see. And that's, it's going to be an issue then from a flexibility perspective. So I hope that makes sense. So you think of the lats, what do? They extend, they adduct, they internally rotate. Well, if I write that down, they extend, okay, they adduct, and then internally rotate. And that's all I'm doing is I'm writing that down. Well, what are the opposites? What's the opposite of extend? Well, extension, the opposite of extension is flexion. So they have to have proper extensibility to allow for shoulder flexion. What's the opposite of adduction? Abduction. So I hope this makes sense. Internal, external rotation. And that's what you're seeing here. You must have proper extensibility to allow for proper shoulder flexion, proper shoulder abduction, and external. So those are the opposites in these planes, in these particular planes. Those are the opposite movements that are associated with the actual kinesiological function of the lats. Look at the biceps femoris. Let's go ahead through this now. Remember, the biceps femoris, for the most part, has multiple functions in all three of the planes. So in the sagittal plane, movement forward and backward, what do the hamstrings do? What is the kinesiological? Don't look over here yet. Don't look here. Don't look on this column, okay? What is the kinesiological function of the biceps? Close your eyes and just think about this. Kinesiological function of the biceps femoris, right? The hamstrings in general. We talk about the biceps femoris because it's going to have a couple of more functions than just the semimembranosus, semitendinosus itself. So if you look at the biceps femoris, its kinesiological function is hip extension and knee flexion. But what else? It does other things. It actually acts as a what? It acts as a external rotator. So must have proper extensibility for this, proper extensibility for this. And if you look in the sagittal plane, forward, right? Like a soldier, sagittal soldier. That's the way I always think about it. It must have proper extensibility to allow for what? If its kinesiological function is hip extension, then it needs to allow for hip flexion. I hope that makes sense. If its normal kinesiological function is knee flexion, which is what it is, then its extensibility issues related to extensibility should allow for knee extension. Does this make sense? If its function is flexion, then proper extensibility allows for the opposite function, which is extension at the knee in the frontal plane, so movement out and back. For the most part, the biceps femoris, because its insertion is on the lateral aspect of the knee, somewhat. It's lateral versus medial, and you can actually see that. So it actually acts, depending on the position of the femur, it acts as a hip abductor. Yes, I know we never think about that, but it actually does. It can actually be a fairly powerful hip abductor, depending on the positioning of the joints, the biomechanics. So in the frontal plane, if the biceps femoris acts as a abductor, then it must allow for hip adduction. I hope this is making sense. If in this, for instance, the biceps femoris is overactive, if it's really tight, you might not get the necessary adduction. Now, I'm going to be honest with you, even though they put that in there, it's just not something that we see in the real world a whole lot. But what we will see, and this is why it's actually important that you do know this, is the transverse property. You see this a lot, okay? Because the biceps femoris actually acts as a hip external rotator. And again, depending on the position that it's in, it can be a fairly powerful external rotator. But what's going to happen is it's got to allow for proper hip and knee internal rotation. It's a very subtle movement, but I'll be honest with you, it can cause a lot of problems, especially when the tensor fascia lata, when the TFL is also, if it's underactive or overactive, depending on the way the other muscles, particularly at the pelvis, are over or underactive, it can affect exactly what we're talking about here. This inability for the femur, right, the femur to internally rotate properly, and to isolate it is a little bit challenging, because normally when we see issues related to inflexible hamstrings and biceps femoris, we see a lot of stuff all up in here happening simultaneously. Look, for the most part, you know this, and if you've read through this material already, you know this does not happen in isolation. We just don't see muscles, individual muscles, working improperly in isolation. But at least you understand the concept here, is what I'm hoping. Last one is the gastroc. Yes, the gastroc has movement patterns associated with it in the sagittal, frontal, obviously, but don't look at this yet. Don't look at that. But what is the kinesiological function of the gastrocnemius, right, your calf, in the sagittal plane? It's its main function for the most part, which is what? Plantar flexion, right? So the toe points down. And what's the opposite of plantar flexion? It's called dorsiflexion, when the toe points up. Okay. So if the gastroc is tight, overactive, way too overactive, just as a for instance, or it just lacks proper extensibility, it's not going to allow the toe to come up. It's going to want to always be plantar flexing, so to speak. And so proper extensibility, one of the reasons why it is important to stretch the calf, massage it out, do foam roller, SMR type stuff on the calf, gastroc, is to allow for proper dorsiflexion. It will allow for the toe to move up. That's in the sagittal plane. In the frontal plane, yes, this is now where some folks kind of go googly eye with this. It's like, oh boy, do I really got to know inversion and eversion? And the answer is, yeah, it's actually pretty important. From a testing perspective, this is probably more of what they would ask you than anything else. So what's inversion and eversion? Remember, it's in the frontal plane. So this is when the foot itself, now we'll use the calcaneus, which is the heel bone back here. If this is my heel, right? It's that movement inward and outward like this. And so the gastroc actually acts as a eversion, okay, functionally everts the calcaneus, and you can obviously see that from where it inserts into the bones of the foot. And so if eversion is its function, is it a strong everter? No, but it is an everter, so it does eversion, and therefore to allow for proper inversion, of the foot, we have to have a gastroc that has a good proper extensibility. Again, you see the term inversion. Okay, we know the gastroc does eversion as one of its multiple functions, and therefore the problem would be it would not allow for appropriate inversion of the foot, right? So, or the calcaneus. Of course, transverse is in the transverse plane. We have internal, external rotation. The gastroc, again, do we normally associate the gastrocnemius as an external rotator at the ankle? No, but it is. And so this is going to allow for proper internal rotation of the femur, not the ankle, but at the knee. Yes, because the gastroc actually crosses over the knee joint. Technically, the gastroc is a two-jointed muscle. It plantar flex, right? But it also helps and assists with the flexion of the knee. But you'll notice that when it actually works over the knee, it acts as an external rotator, or at least it assists. As an aside, we see a lot of this more honestly when we're talking about the foot being planted, versus just like the foot coming up into a position. We see it in both, but it can really be an issue like when somebody's running and they plant and the gastroc it does not have proper extensibility or it's overactive. It can cause problems at the knee and the ankle. It's a pretty strong muscle. So if it does not have proper extensibility, you're not going to get proper internal rotation. So what does the gastroc have to do? It has to allow for dorsiflexion, it has to allow for inversion, it has to allow for internal rotation. Therefore, if you can reverse engineer this, you can basically say that the gastroc is a plantar flexor, an everter, right? Eversion. I'm not even sure everter is a word, but we have it on video now. So, and it's a external rotator at the knee. So again, if you get into, for instance, corrective exercise, a lot of really, really good, interesting stuff as you move into that sort of level of interaction with clients. But in this case, again, the table helps you to understand that, and they're only giving you 3 examples. Now, just keep in mind for a second, if you were to take a muscle, let's just have a little bit of fun. Close your books, pencils down, pens down, everybody. Let's take a muscle, and let's take a fairly complicated muscle such as the pectoralis major. Okay, pick your pens up. Tell me what the main kinesiological functions are for the pectoralis major, and don't look. What are they? In the sagittal plane, what does the pectoralis major do? What's its primary kinesiological function in the sagittal plane? Correct. It's shoulder flexion. So shoulder flexion, that's one of the kinesiological functions of the pecs. What about in the frontal plane? What does the pec major do in the frontal plane? Well, it's just like the lats. It's an adductor. So I can write adductor, and I'm looking at my pectoralis. What else does it do? Just like the lats, it's an internal rotator. Okay, your pecs and your lats are very powerful internal rotators. So they're going to say internal rotation. Now you would say the same thing. Proper extensibility of the pectoralis major should allow for what? Shoulder abduction, shoulder external rotation, and shoulder extension. See, they're just the opposite. So, see, you got it. So you can do that with any muscle of the body. Some of the less complicated kinesiologically biomechanical perspective muscles, like the biceps or the triceps, not as complicated. You can see where proper extensibility is needed to allow for, in the biceps case, extension at the elbow. Okay, then the triceps would allow for flexion at the elbow with proper extensibility. Do not confuse the terms, and do not confuse that when we're talking about flexibility training, we're not talking about concentric and eccentric contractions. We're talking about the ability of the muscle to be lengthened and stretched, not to go through concentric contractions. It's not what we're talking about. Not with this. Okay, so please keep that in mind. And look, if you have any other questions, you can obviously leave them in the comment section below. Please make sure that you have subscribed. And by the way, I hope this makes sense in chapter 14. But if you would subscribe, we'd appreciate that. Of course, you can hit the notification bell. If you want to know any more, for instance, or really get to know all of the materials that we have in our exam prep, then for sure click on the link that you see below there as well. As always, we're here to help you to pass your NASM exam. Give us questions, and we will be more than happy to reach out and assist you. By the way, go back also to our Facebook group, right? Our NASM private study group, where you can also ask questions and engage with other like-minded students that are prepping for their NASM exam. Have a great weekend, and we will see you next week. Thanks.